We're going to run a 2-sample t-test by comparing the average saturated fat content for these 2 major chains in terms of making and selling pizzas. So first thing we have to do is the parameters. Well done, Jonathan. You got one for us? It's okay if you don't. I know you've been out of the game for a week. Now, here's the deal. If there's 2 of them, we got to say which one it is. So which one do you want to start with? Mu D, mu subscript D. Okay.
Represent brand pizzas.
All right. So I'm going to say the average fat content in brand D pizzas. And if you wanted to write Domino's, you could. Okay, then don't. All right. And then the nice thing is just copy and paste this, but you're going to change your subscript D to be PH or P for Pizza Hut or brand PH. Did I ever tell you the story, speaking of PHs, of Miss Burns' only detention in high school? Did I tell you this one? Yeah, I did. Do you remember? Oh, it's such a good one too. Because I found out like years after we started dating that she had gotten a detention in high school. So I like reevaluated, like, is this going to be, is it going to work out? Right. She went up a down stairwell. I know. It's a huge. I follow the rules, right? I'm a rule follower. All right, who's got the null hypothesis? Who's got the null hypothesis? There's 2 ways to write it. I don't care which way you choose. What are we assuming right now? They're the same. Their average saturated fat content is equal. So you could write. I'm going to write it that way. Maria, I'm going to write mu subscript D minus mu subscript pH equals 0, but you could also write mu sub D equals mu pH. That's also fine. Do you need to write both? No, just pick one. Yeah, Thomas.
Why are we using mu?
Can any of the girls?
Because it's a t-test.
Because we're doing means. We're doing averages. No more proportions. And you were here last week when we did one. Were you not?
It's been a while.
Yeah, that's fair.
I was focused on God.
I cannot compare or compete with that, so sounds good. All right. Now, is there anything in the problem that's going to tell us what symbol we're going to use in the alternative hypothesis?
Do the 2 pizza chains have significantly different mean saturated fat content?
Just says different, so exactly, Maria, not equal to, right? But if it said, is there a significant difference showing Domino's has more or Pizza Hut has less, that would tell you something in terms of the symbol. But for our purposes, we're going to use not equal to. So I'm hoping by now, right, and if not, hopefully this will help. But the moment I write not equal to, I know that when I do my sketch, I'm going to be shading in both tails. So whether my t-test statistic is positive or negative, I'm going to be caring about both. All right, and shading both directions. All right, so that's a good mental image to have as you write that. Okay, now we're ready for the assumptions. Who's got one? Remember, it doesn't matter the order. I like to go in order, but you can go in any order you want. I don't care.
The average fat content in one brand of pizzas does not affect the other.
Okay, so now he just said the average fat content in one brand will not affect the other. So what is he actually doing when he says that? You're doing the very last one, which is totally fine. We can do the last one first, right? Speaking of God, the first shall be last. So let's do it. That's fine. I'm cool with it. So brand, there we go. D, fat content. It doesn't matter, does it? Will not affect brand pH. So this is assuming that the two pizza chains all right, have independence. What do you guys think about that? Any thoughts? Do you think there's any relationship? Right, I'm sure there are many people in the audience that have had both chains of pizza. Do you think there's a relationship? Could you think of a way to make a relationship? Yeah, Tom.
I mean, they could like try to make it so that one theirs is like lower, so they can advertise like, oh, ours is healthier than theirs.
Interesting. Okay. So you think they're buying the other competitors and like analyzing what they do? Yeah, probably.
Also, I heard that like most pizza chains they use the same cheese, so like that might have also.
That was my thought. Is like maybe their ingredients are similar. They're getting from the same distributor in terms of the stuff they're using to make the pizzas. So that would worry me. All right. Now I think we should go ahead and do the other independence assumption. What's the other one? Exactly, right? So if we're talking about just Domino's pizzas, I look at that one, not going to have any relationship. All right. Same thing with Pizza Hut. So one, pizzas, fat content won't affect others. Now, they're not really giving us a whole lot of information here about how they're getting these pizzas or how they're sampling them. But I'm hoping in the problem it says something about a random sample. Does it say anything on the very first page about a random sample? It doesn't. So what do we need to write? That sentence we always are going to write if it doesn't say randomness.
These pizzas are a good representation of this college.
That's right. So these pizzas are a good representation of all pizzas. All right, let's do the 10% condition. What was the sample size for Domino's? It was 20, right? What was the sample size for Pizza Hut? 15. Let's multiply by 10. What do we get? 200 and 150. All right. I don't know what they're talking about, whether they're talking about the United States, the state of Texas, the city of Houston, about all these different chains. But, I'm pretty confident. I've actually probably eaten over 200 Domino's pizzas in my life. All right. Don't judge. Okay. They're delicious. Well, in college, they're $5.99 a pop,
$5.99?
Yeah.
Oh no.
Close enough. Yeah, they'll deliver. Yeah. Check them out in April. I mean, don't. Eat at the dining hall. The dining hall is really good. It's always rated like the top 5 in the country. So, in Notre Dame, it's really good dining hall food. Huh? I mean, I went to school there, so it wasn't free. Okay. Everybody good on that? So our sample sizes are not too big or too large. Remind me when I'm done to tell you about my experience at a restaurant on Saturday night. It was fantastic. This past Saturday, yeah. So good. Oh my God. Well, after the video. Okay. It's a teaser. All right. I'll take AP Stats. Okay. Where to next?
Our sample sizes are not too small.
So that was what we would do if we were still in the world of proportions. But we're not. So we got to do the normal population assumption. So do I know what the saturated fat content is for all of the pizzas made by these two chains? Right? No, right? But if I did have that data and looked at the histogram, it better be what? Normal. I'm going to go with symmetric and unimodal. So the population histograms, don't say proportions. All right, so I'm going with that the population histograms for both chains pizzas, and I'm looking at them separately, would be unimodal and symmetric. So in my brain, I'm thinking about two separate histograms because now, once you write this statement, they did give us data, right? For Domino's, we got 20 data values. For Pizza Hut, we got 15. So what am I going to do with those data values? And I already did, right? And what am I going to do with them now? Make a histogram, exactly. And what am I hoping to see? And roughly symmetric. And if I don't, I'm going to make a comment, all right? But I'm going to keep going. Don't just stop.
And it's okay because this is a very small sample.
Well, actually, we're going to see in a moment, it's actually the flip side of that is I would feel better if it wasn't a small sample. And these are small.
Yeah, that's why I'm like, it's okay if there's like an error because like, it's a very small sample.
So no, it's actually not okay that there's an error because it's small. We're going to make a note of that's why we're making a note, Thomas. And if it was 150 or 2,000 or 1,500, right, then those are larger samples. I'd feel less worried. All right, so here we go. Let's see what it is. Oh, also, if you go to the next slide is blank, and you can put your histograms on that slide if you like. That's where I'm going to put mine. All right, so I'm going to turn my stat plot on, or plot one on. So go to second y equals, which is stat plot. Go down to histogram. That's over in a histogram. And I'm going to use just list one, this is my Domino's one, okay? So graph, and then zoom 9. All right, what do you think?
It's unimodal and symmetric.
Roughly symmetric, right? It's definitely not symmetric, roughly symmetric. So I'm going to sketch this as for Domino's. So Domino's. Okay, let's do Pizza Hut. Now, you can do the second, you got two choices here. You can go back to the first stat plot and just change instead of list 1, make it list 2, or you could turn stat plot 1 off, go to stat plot 2, turn that one on and make it list 2. I just always go to the first one. So I go to second stat plot, go here, and it's already on. And I go down to where it says list 1, bless you. I go down to where it says list 2, or list 1, I make it list 2. So hit second, number 2. Second, the number 2. And this will give us Pizza Hut. All right, I'm going to hit zoom 9 again. So I can recenter on that. What do you guys think? I think it's got one hump at the beginning, right? These up here. But am I really thinking roughly symmetric? No, not really. Bless you. And it looks like there's even a potential gap going on. All right. So I'm going to make a note here, Thomas. Right? I'm going to say the Pizza Hut histogram is not unimodal and roughly symmetric. And why is this concerning to me? Because how many pizzas did they sample? 15, right? And even if it were 20, it would still feel small to me. So I'm going to make a note, like I'm concerned because $15 is a small sample. All right, I'm going to keep going, but I do want to make a note of my concern that the histogram for our sample data was not unimodal, roughly symmetric. You just have both turned on. So let's turn off the first one. There you go. And then hit zoom 9. There you go. Remember, if you're ever having questions about calculator buttons, let me know. Happy to come help so you can be ready for May.
You'll be there during May, right?
I won't be in the room, no. Can't be in the room. Because they'll be worried that I'll help you. I wonder if you could like make a fat head out of me. You know, the things that you put. Well, no, it's like, this is a long time ago, back when I was in high school. They would like take like an athlete and like make like a life-size thing, like a big giant magnet that you like put on your wall or something. Like maybe you just like put me up here, you know, doing like that.
You beat it out. I always feel like you're like watching it.
Okay,
They definitely will see that.
what are we ready to write? The conclusion. No, we haven't done any math yet. I know, this is going to be like a half hour that you got to do in like 10. Have been satisfied. I'm saying we're taking a long time to do this, Joseph, but if this was the AP exam, it'd be a much faster process. So I will use the T model, and what I want you to do right now, all right, I'm going to put with, and I want you to leave a blank. How did we determine degrees of freedom last week? N minus 1. Very good. All right, sample size minus 1. Unfortunately, it's not sample size minus 2 for this because there's 2 groups. So we have to wait until we run the test in the technology, and it will tell us the degrees of freedom. So just put a little blank here with blank degrees of freedom to run a 2-sample t-test. All right, so when you're done with this sentence, the next slide is where we put our histograms. So if you go to the one after that, that's where I'm going to do the math. We're almost done. I always feel like once I finish this statement, I feel like I'm home free, right? So much closer to being done. So close, yet so far. All right, so let's write down all of the pertinent information. There's a lot here. All right, and there's a lot I don't know. Because right now, do I know my sample statistics? Do I know the average fat content for these 20 Domino's pizzas? I do not, right? So the computer or the calculator is going to tell me that as well. So remember skipping this one, going here. So here we go. So I've got sample size for Domino's is 20. All right. Our Y bar for Domino's, I don't know. Our standard deviation for Domino's, I don't know. Let's do the same thing for Pizza Hut. There's 15 Pizza Hut pizzas. I don't know the average fat content, and I don't know the standard deviation. I'm going to leave those blank. Right? I will come back and fill those in. So here's the formula we're going to use. T, and notice I'm leaving the degrees of freedom as degrees of freedom right now, because I don't know, equals Y bar of Domino's minus Y bar of Pizza Hut. If you wanted to, you could put these in parentheses and subtract what? 0. But do you need to write minus 0? No. Remember what I told you? 99% of the time, 9 times out of 10, whatever you want to go with, it will just be 0. The problem will tell you, I think I have one that we'll do at some point in the review process in April, that it's not 0. So I'll make it very clear, like here's what it will look like if it's not going to be 0. Over the standard error for that difference in our sample means, and that formula that, again, you do not have to have memorized, is the square root of standard deviation squared over n plus. I know. It's just hard not to, because like I've just been so ingrained to do it fast on the AP exam, you know? So it's hard to be like, oh, time doesn't matter.
You should take it.
I should take it? I do every year they release it, I take it. I mean, not every time. No. Yeah, it's fun. It keeps me fresh. Just like every 3 to 5 years, I take the SAT again, just to make sure.
Okay.
Not like in person. Like I just print it out.
Just make sure you're good at it.
Well, make sure I'm not missing anything. Like, oh wow, I don't think I've covered this, and it's on the SAT. I should cover it.
Just make sure it's in the material.
Every teacher should do that. I think that's just basic good practice.
Do you time yourself?
Huh? Thank you. I do time myself, but I don't stop if I miss it, I keep going. Like I'll make a note, like, oh, I didn't get to 2, whatever. I'm finished. Okay, you ready to run it so we can get all our stuff? All right, so turn your calculator on. Go to Stat. Over to Tests. All right, and which one are we doing?
Two-sample t-test.
T-test.
Yeah.
All right.
I knew that.
Think of your favorite brewer at the Guinness factory. Okay, Joseph? William Seeley Gossett. All right, 2-sample t-test. Do we have data, or do we need to type in the statistics? We have the data, so leave it at data. List 1, list 2, we're good there. All right. What about our alternative hypothesis?
Not equal.
So we're good there. Pooling!
No.
It's okay.
It's doing me.
Are we doing a proportion test? No. Remember, proportion starts with P. That's when you pool. Mean or average does not start with P. So we're not pooling. So when it says no, and guys, just remember, what's the default?
No.
No.
Well, it's a mid-school, it's a proportion.
Pool of proportions. Calculate. All right. So let's fill in our stuff. I know you guys want to fill in the test, statistic, and p-value, which we'll get to. But I want to do my my y bars. So I have 11.25 for Domino's. Did he give me a unit? Is it grams? I don't even know. No? Okay. It is grams. Look at that. 6.53 for Pizza Hut. Standard deviations, you got to scroll down for a second. 3.19.
Wait, what'd you guess?
Just scrolling down. 2.59.
No, 6.53.
Did somebody else get something different? Did you get something different, Joseph? Is it the X bar? I'm just using Y bars.
No, I don't know.
Okay.
It's 6.7.
Okay, so you're close. You just typed in a number wrong. Or you have one less or one more. Yeah, no worries. Okay, and then did you guys see the degrees of freedom? 32 point, I don't know which one did you hear, 757. All right, so let's go back up. Remember that statement you left a blank? With 32.757 degrees of freedom. 32.757 degrees of freedom. Again, you do not need to ever calculate that by hand. It will always be in the calculator. So 32.757 equals 11.25 minus 6.53. Here's the fun part. Filling in the formula. Yay. 3.19 squared over, it was 20, I believe, plus 2.59 squared over 15. Again, most AP exam scoring guidelines I've read in the past decade have said that as long as you state the test you're running or show with a formula what test you're running, that checks the box of telling the readers what you're doing. Okay? You know I'm going to do both, right? Make it official. Yes.
For the first part, we said as long as you say the test you're going to do.
Yeah.
Is that the conditions have been met?
Yes, that part.
So if I did that, I don't need to do this.
Correct. But you know I'm not just teaching you for the AP exam, right? Because some of you may take stats in college. I hope many of you will.
Yeah, that's the thing. I would have been struggling with time and kept thinking.
And now there you go, shave it off. All right. So our T test statistic is 4.823. All right. Remember, I'm going to draw my curve. What did I just draw?
Curve.
Which model?
T model.
The T model. Thank you, Diana. Appreciate you. Now 4 is like, whoa, that's so far over. 4.823. Notice, why am I doing the other side as well?
Because you said
Yeah, they're not
differential.
equal.
It's a two-tailed test. You got it. All right, let's get our p-value. I think this one actually has scientific notation for the p-value. So it's 0. So we got to go 5 over, so 3.15. So let's go over. All right, so 0.00003. I'm hoping that you've done this now a few times with the scientific notation ones, that when you see scientific notation, what are you thinking about that p-value? It's tiny. It's super small. Like it's really close to 0. I didn't say what alpha I'm going to use, but you know I'm always going to use.
0.05.
And how would you compare this p-value of essentially 0
It's
to that?
below.
It's below. So if your p-value is below alpha,
You
you reject the null. You do have enough evidence to say there is a difference. That'll be my statement. And don't worry, I know some of you are noticing where it says further comments. I'm not going to do anything else after we're done. All right, but just to know, you should know that everything is linked here, that I'm about to write that there's a difference between the average fat content in Domino's pizzas and Pizza Hut pizzas. What is, in my mind, what's the obvious follow-up question? If I'm saying there's a difference, what's the next question?
How much of a difference?
Exactly. Right? And then I would run a confidence interval. All right? We're not going to, but I want you to understand of like why these things exist in the same land, the same lesson, same world. Okay? So there is a difference. And maybe this is why I prefer Domino's to Pizza Hut, because if you just took a quick little look at the sample means, the Y bars, you would notice that the Domino's one is pretty high compared to the pizza one. It has more fat, so maybe that's why it's more delicious.
Does this reflect real life average fat content?
Like, did I get these numbers from a real